Everyone, and thank you for joining the July 2024 VMware TAM customer webinar. This webinar is organised by the VMware TAM organisation to provide our customers the opportunity to interact with great speakers about content that will help them get the full benefit from their VMware software. Before we get into today's session, there are just a couple of quick announcements. Our next TAM customer webinar will be on August 15th. We'll be covering the hot topic of what's new in vSphere 8 Update 3, looking at all the new features and enhancements. Your interaction during this webinar is important, so please make use of the Q&A feature of Zoom to ask your questions. If we are unable to answer your question during the webinar, please be sure to reach out to your TAM and ask them to follow up. At the end of today's session, you will be prompted to fill out a quick survey related to the value you received from this session and any topic suggestions for the future. Your completion of the survey is really valuable to us, so we'd really appreciate if you could take a couple of minutes to fill this in. And lastly, this webinar is being recorded and your TAM can make the recording link available to you. After a few months, the recording will be publicly available on the VMware TAM Services YouTube channel, which you can access through the QR code in the top right of the screen. So that brings us to today's speaker and topic. It's my pleasure to introduce Chaz Cockshoot from Product Management from our SDE division. Chaz is going to be talking to us about the architecture and use cases of our Edge Compute Stack solution. So over to you, Chaz.
Thank you, Amy, and thanks for the opportunity to present by way of introduction. Let me get the clicker working. Chaz Cockshoot, I've been in VMware coming up to 9 years. I started in core working as an SE, working alongside TAMs on a number of UK enterprise accounts. So I've been there, appreciate the technology, appreciate the role TAMs do for you. So what I'm going to do, couple of sections here. First of all, I'm going to talk about the edge. Then I'm going to go through use cases as promised across a number of industries. Then we'll dive into the product itself. So let's just start with a quick definition of software-defined edge. And you'll note we do have a dash between the software and defined in our division name. So this is all about distributed infrastructure, running workloads primarily outside data centers, outside clouds, placed close to where the data is either being generated or consumed or a system is being controlled. And that's a little bit of a dry definition. So let's put that in pictures. Our VP talks about edge being the competitive battleground. The reason we're seeing an explosion in edge and the reason we exist as an edge compute division is to serve these markets, whether it's retail, healthcare, logistics, energy, security, even defense and others that I'll show you. A lot more IT is being put in there. Now, at this point, a lot of people say, well, I've been doing the edge for a long time. And it's true, there have been IT workloads out at the edge that we've managed, and they're typically slow moving, and they might be IT for IT's sake, file and print servers, logon servers, the things that make IT work. And then on the other side, you've had OT workload, a phrase you'll hear me mention a number of times during this presentation, operational technology. And that's the stuff that makes real life work, makes your electricity go, makes your forklifts work and factories work. And really what we're seeing is the bringing together of the two of them for a number of reasons I'll elaborate on. But one thing is true is every single edge is different. We could spend the entire 90 minutes trying to define edge, just like you tried to define cloud when it first came out. So for that reason, our division takes a vertical approach to our go-to-market, to our solutions and our reference architectures. And I think we're unique in the industry in doing that, or we're unique within VMware. And the markets we're focused on, these were primarily based on the size of the market and our existing relationships. Number one was manufacturing. So we work a lot in Europe, in Germany and elsewhere. And we'll talk about them, the car manufacturers and the big industrialists. The second is retail, which VMware's probably got the biggest amount of experience at the edge to date. Like I said, perhaps with those IT workloads. And then we've had an incubation bucket, industry. And that list, every time I present, I'm adding another industry in there because people are coming to VMware to help solve in those spaces because they know us, because they have experience with us, and they know that our technology can solve in that place. So I'll talk about energy, I'll mention defense, healthcare, and I've also got a transport example. So please don't limit in your head that we're just addressing a couple of the markets. And the goal here, as ever, is to take VMware's horizontal solutions compute, storage, networking, containers, management at scale, all those good things we do, the good attributes, and apply them to each industry. And that's why we need expertise. So we have expertise in our teams. I've had 15 plus years experience with retail, and I've done defence for a decade with the UK government. So we have our own skills, but then we work with partners, customers, and the ecosystem, because Edge is not a singular vendor or a single, you can't solve it with a single solution. And you'll see that as I jump through. So if I move on, apologies, I keep moving the mouse away from where the clicker will work completely. Why are those industries applying more edge compute? Why are we moving from, as I said, perhaps IT focused workloads to workloads that are more focused on OT? If you think about the disruption that's happened in the market, so if you think of manufacturing, Tesla's the best example here. Tesla totally upended how you build a car plant, how you build a line, how you adapt. And then you've seen personalization adopted by the likes of the Volkswagen Group and others. So more and more technology is going in there. More and more technology to build the thing, more and more technology to keep costs down in terms of maintenance and understanding when failures are going to occur and keeping quality up. Retail and logistics. There's an obvious one who disrupted there, and they've been data-driven since the day they sold their first book, and that is Amazon. And what they did for e-commerce, everyone now wants to do in the physical world. So if you think of e-commerce today, shopping on websites, everything you do is captured. Where you click, if you leave something in a basket, if you increase the size of a product to zoom in, does that mean that the thumbnails are low quality or you need glasses? I've genuinely had adverts pushed on that way. But in seriousness, it's all about capturing those data points to understand and optimize your business, but also give a better customer experience. Understanding where goods are in a process. Have you got returns going to one store that could be put on the e-commerce site in a couple of days? So it's joining up e-commerce in retail and logistics, and it's also providing ultimate customer experience that we'll dig into. Kind of call that clickstream at the edge. The energy market, somewhat similar to manufacturing, there had been a bit of a laggard with everything physical and everything discrete components. But again, shifts in renewables, shift in home generation, solar panels where you feed back into the grid, means there's a lot more complexity to manage and there's a lot more change. So again, all those software-defined features you're familiar with get applied. And then, as I said, this extends beyond emergency services. We've done some work in the UK where if you lifted up and looked in the, I use the international phrase, the trunk or the boot of a car, a police car, it's full of equipment and it's full of wiring. It's all proprietary and it adds weight and it adds complexity. When really they want access to the applications and they want to get the data they capture into case systems to do their job and serve the community. So again, we're helping solve that with our technology backend. So a couple more positioning slides and discussion on workload, and then we'll get into the utilities, the different verticals. So at this point, someone always asks me, why put compute at the edge? Why not put it in a cloud somewhere, private, public? Number one, there's too much data, and we can't escape the laws of latency and the laws of gravity and how far it takes to move noughts and ones on. More importantly, you quite often don't want all that data. There's too much being generated. You'll never analyze it. You'll never catch up. So it needs to be processed locally. The poor connectivity. A lot of these sites, I hope you'll appreciate, don't have always on connectivity, but they need to run and they need to work because they're doing important, as I call it, in real life functions. And then the last is the ubiquitous regulatory requirements. You can't move that data. You need to do it local, whether it's facial recognition, you use it for the purpose and then you keep it, you can't store it. So there's a lot of reasons technically and regulatory why you're seeing data and processing at the edge. And then you're seeing disruption in these industries. And the use of technology really helps drive transformation and differentiation for businesses. So if they want to survive and compete, they need to adopt this. So this is quite a big statement, from Gartner. More than 50% of data will be created and processed outside private or public cloud in the next 3 or 4 years. There's a massive increase there coming, and the icons kind of show you the use cases I've talked about. So what's driving it? What are the actual applications that we're seeing? I've already talked about what I call big app, little app, where you have e-commerce type sites that are extending down to the edge for buying online and returning in store, or capturing data to inform companies' operating models. But we're seeing a lot more of those emerging applications that kind of have local loop processing. That's a phrase you're familiar with. The predictive maintenance, quality inspection. Predictive maintenance is huge, whether it's a travelator, an escalator in an airport, or something in a factory. If you can say that's about to fail, think of the time and ROI you save. The actual dollars or euros, pounds you can save by getting that fixed before it breaks. There's a lot of video out there, a lot of video processing. It's seen as the solution because it's sometimes non-invasive. You don't have to put sensors and weights and physical things everywhere. And that's being used across all those industries for worker safety, for detecting what customers are doing, for inspections. So that's generating data. And every presentation has the AI ML, and here's my one in the middle. It's a huge growth. It's genuine. It's real. I'd say about 80% of the use cases we work on involve AI and local data crunching in some way, whether it's computer vision driven or it's from sensors. And they're doing a couple of things. They're doing local loop processing, or they're feeding that data back into companies' data warehouses to make their operating models work better. And then finally, we've got the virtualization of those OT workloads. For those of you familiar, in ESX version 7 update 2, we introduced support for real time in our hypervisor. What that allows us to do is give deterministic outcomes in terms of timing to certain processes. And that's really important for programmable logical controllers, or the protection and control you see in power substations. So now we're able to take workloads that we weren't able to host before and start to bring them onto a virtualization platform. As I'll explain, that allows you to apply IT-like attributes to them, like rollback and features. So that's where we're heading. But let's start talking about some of the issues it highlights. In a nutshell, this slide is talking about the fact that we're getting sprawl again, which is familiar for those of you who've worked with data centers over the years. Every app, every function, let's not call them apps yet, every function that someone's putting in there comes with its own piece of hardware. And every time someone has a new idea or a new process, they bring a new piece of hardware. I've been in factories, I've seen some great examples. I've seen laptops balanced on the side of things where people trial out cameras and predictive maintenance. That's not a way of scaling up and out. So what's happening is more and more and more and more of these are getting created. And that's why people are turning to the edge computer vision to ask us to help solve that and bring together that expertise we're building in the vertical markets, but also the IT expertise we have as a business together to help solving it. As it says here, we need a strategy to solve this. I hope you'll all agree that edge is different from controlled environments of private and public clouds. Scale is probably another 10x. We're typically not talking hundreds of hosts or thousands. We're talking thousands, tens of thousands, or hundreds of thousands. Networking, and this comes important when we talk about the architecture in the second half. There is no such thing as a reliable network and guaranteed connectivity. So we've had to think about how we manage things. If you think of the fleet management that happens in your public and private data centers, it assumes it can connect to the host. So centralized management tends to talk a lot to the hosts and communicates them, and it uses a central thing for functions. Our approach is different, is to take the pool type approach. You're probably familiar with your, can't see it because of the mirror, mobile phone and other home devices, where those devices, when they have the connectivity, independently pull the information down. I've touched on the hardware and protocols. We'll talk about it in each area, but we're expanding the use away from just TCP/IP, and let's call it general hosting type hardware. This purple one, the limited on-site personnel, is key. You can't assume there's IT people at the edge, which is someone's store or manufacturing plant. They're often remote. They're often rugged. You need downtime to get them on. So the more we can do zero touch or no touch provisioning, the more we can automate and take some of those principles from the public and private clouds around fleet management and apply them to these devices, the more we can have an impact and limit things like downtime, allow agility. And security, I said I did security for a number of years in various roles, and it always gets the right-hand side of these slide decks somewhat unfairly. No, security needs to be built in from day one. We're deploying in untrusted environments, uncontrolled environments. Communication may be over a network that you don't control. You need to avoid people stealing the data, stealing the device and trying to reuse them. So you need assertion as to should that device connect? And if it does connect, what's it allowed to do? And who owns it? And we can do that using a lot of the core value of ESXi and vSphere in terms of TPM chip, a secure boot, and others that I'll show you. So that's the kind of outlay in the first pause. And please, if you've got any questions, please post them and we can talk as we go along, and I'll answer some at the end. So let's just talk about and move on to manufacturing as one of the first verticals. I'm going to cover three. If we put a summary on this is the three key ones that manufacturing are struggling with. One is that technology integration. It's great having Industry 4. It's great having new initiatives. Let's digitize everything. But if you haven't got a platform strategy there, it's hard to move beyond that initial phase and scale out. Security and compliance, it's starting to move from the right to the left. But again, it's massive. The investment and what these things produce and control, everything needs to be secure. That's been one of the barriers, I think, over the years of connecting the IT and the OT world. Dive into it in the architecture. And sustainability. It's not just there to make sure there's three there. Power consumption is a massive thing for everybody. Making sure that things run efficiently just for financial reasons, let alone ESG reasons, is key. That's what's driving the change in CPU architectures. That's what's driving low power. That's what's driving the desire to have smaller boxes and consolidate. So there's a lot of key. So I've done a lot of talking with a number of slides, 12 I see so far. So let's put this visually for those of you watching. Hope you're all seeing a video stream. This was taken, we did this with Intel and a couple of partners at the Hanover Messe Fair in Germany, which is the big industrial fair globally every year. So I should have put a poll here to see if people can guess, but there's four things going on here. I'm not sure if you can see them. So one is you have the robot arm that's being moved and being controlled, along with the conveyor belt. That's two things that are there. If you look up in the, you can see my mouse there. If you look up at the screen, we have what's called a HMI, so a human machine interface, the interface which you operate. So that's a third one. You can also see a camera. It's behind the monitor in this demo, but you can see the output on the screen there, the green object. So there's a camera, computer vision, that's feeding, and there's some AI going on. There's some decision. You can see the word found just there. So this is all happening on a loop. There's four different workloads there. And if I move on to the next slide, what you can see here is, first of all, someone trying to get their arm ripped off by the robot, but the robot wins eventually. There we go. But what you're seeing is the four workloads consolidated together on a single box. So a single box running VMware's hypervisor. So Intel Tiger Lake, for those of you who are into CPU families, 8 core with iGPU. So it's not a huge device. It's an industrial PC, a standard specification. And we have 2 real-time workloads running on there, programmable logical controller and the robot control. And then we have the video output, the HMI, and the inferencing with the GPU. So what we're able to do there and demonstrate, and this was this was our first proof point to get people talking, to go, I didn't know VMware could do that, is we can reduce the amount of hardware. We can certainly increase agility by, rather than proprietary single-use hardware, single device, you can choose a platform and then add software to it, a common concept outside OT. Because things are virtualized, they can be managed in a more agile way, roll back, roll forward. And you can start to manage that OT in a similar way to IT. So we've put this in a combined slide. Today, what you've just seen visually looks like that in diagrammatic form. You've got individual industrial PCs, that's what IPC stands for, and individual programmable logical controllers, all bolted around a plant or a factory line. That causes sprawl, it increases your security risk, and as I've said, is inefficient. Because if you can't treat this as a whole, you've got dependencies that are hard to understand, and maintenance requires more downtime. There's a quote there with car retailer that we talked about there in our keynote Explore last year. And his view is we need to solve this. And so we've been working with them and other industry partners to put this on their production lines. And typically they want to consolidate at the plant level. So per line, sorry, not plant, per line. So if you look at how we've rethought that and brought it together, you can see on the right-hand side here, a single stack hosting those functions. And then we can bring in the IT type concepts that are familiar to ourselves and yourselves, but easy updates, roll back to a point in time. So if one of those updates fails and maybe there's some interdependencies, you can go back to a point in time. You've also got a single point for monitoring and observability. So lots of benefits we can bring. Some are very familiar to those of us who've worked in IT, but it's what OT is demanding. And that's really what we talk about when we bring the 2 worlds together. So again, if we talk about that, VMware's reach typically has been in those public and private clouds, and perhaps to the server room in the corner of these factories. I've worked in Wolfsburg, Volkswagen for a different vendor, and it's huge. It's not even soccer football pitch size. It is a city. So they have server rooms dotted around the place, but then you get OT individually. So the goal here is to bring those worlds together and treat it as a whole solution. I'll show you an architecture slide in a minute. So it's all can be managed as a single entity, a single product in agile type terms. So I've mentioned security. Security is extremely important here. There's a framework called the Purdue model. If you Google it and click on images, the second or third one has a really good diagram that shows this. And what it's about is the logical separation that's required. And again, for those of you familiar with software defined, what we're doing is starting to break down those physical separations and making them logical. So typically, we've stopped at level 4 and 5, the enterprise IT network. Now you'll see we're moving down into levels 3 and 2 and process control. So level 2 is where I've just shown you consolidation of a lot of those, like control and automation, SCADA, and the UIs and screening and computer vision. But we're now moving into process control, where we can virtualize those programmable logical controllers. Siemens, one of the leading manufacturers, released their virtual PLC last year, and we've been working with them and others on the market. And that brings some challenges. It brings the challenges of dealing with new protocols, dealing with real time, and also deciding where we stop. So today our goal is a lot of those PLCs do monitoring, for instance. They're not mission critical. They're not in the paint shop, for example. It's kind of an 80-20, 90-10 rule. The 10% is the high criticality where they need 2 physical pairs with millisecond switch off. So we can start to virtualize those PLCs and bring them together, and start to take on more controls and deal with things like PTP protocols and security lower down the stack. So that's the journey we're on. I'll just close with a couple of examples of, a couple of architectural ones on the manufacturing piece. So physical PLC versus the virtual one. Just to highlight the point again. Typically today, you have a physical thing. Go on Google, you can see them on the web, or you can buy used ones on eBay. Those physical PLCs are really a microcontroller in themselves, have an embedded real-time OS and the runtime all in one physical item. What we're doing here is inserting the software-defined layers, as we have done elsewhere. And then the PLC program, which is the smart bit, is delivered as software by the vendor. There's benefits to the vendor as well. They have agility. They can do more refreshes. They can add more features. Whereas before, you'd have to physically replace that. So that's how we're doing that. And actually, for those of you who may be attending Explore, you'll see we have either of the Explore sessions, we have a mini factory, a mini Siemens factory, all controlled by this virtually that you can see, and there's some links to videos at the end. So if I pull this all together in architecture I've got a couple more slides just to conclude the manufacturing piece. This is what it all looks like pulled together. And as I said, there's a mix of, what you might traditionally see in public-private clouds, the IoT analytics and the app workplace, edge compute stack on the edge of the plant line, consolidating some of those management layers. And then you see it on individual production lines, where we're virtualizing the PLCs and the non-real-time apps, and then actually communicating to those devices over the likes of Profinet and other industrial Ethernet. And we've been working collectively with our advanced network department on the smart set to make that happen together. So real-time, not just real-time compute, but real-time networking is something that is being developed. So I dived into the technology there. I'll wrap this bit up by just talking about the use cases. So summary of use cases that we're working on. And these are the kind of stories and interests that, I encourage, if you're focused on the IT side of the business, which, we are, and it's generally who we work and have our relationships with, listen out for these, because this is where IT can start making OT's life a lot easier. Computer vision for quality inspection, as I said, that's almost ubiquitous. It's everywhere. Everyone's doing it, but find out how they're doing it. They're doing it with discrete components. How are they streaming the data? The middle one, OEE, overall equipment effectiveness. This links to sustainability, but also links to companies' bottom lines, top lines, how much money they're making, how much waste there are. It's how efficient that equipment is, how efficient it's operating. It's a standard industry measure. So again, that's data capture, analysis, and fed back. And then the last one, the secure edge. It's important as more software goes out there, there's more IP in there, that it is controlled. And again, that's something that we've always baked into our solutions, is to ensure that we can securely distribute these apps and also securely update them, manage them, and ensure that access control is provided. There's also worker safety for computer vision. We see this in retail as well. It's amazing when you see what they can do. They can actually model and use digital twins, for example, to look for collisions, redesign the factory layout. And again, it is about worker safety, but it's also about lowering your risk, which means lowering your insurance, making sure you capture stuff and make changes so it doesn't happen. Virtualizing those HMIs, human machine interface, a terrible acronym, touch screens that actually operate these. As we said, we centralize patching, reduce the ingress points where people can plug USB keys in, because if it's all VDI type technology or thin desktop. And then virtualizing the PLCs, which I think I've covered enough in this presentation so far. And again, it's all about those software defined attributes that everyone knows about. So just an example customer. This is a machine builder. They make, I don't have one in the room, soda bottles that put your fizzy drinks, you pop in, thousands a second, thousands a minute. And again, so rather than being a permanent production line, they build these and then send them out. So again, this isn't going to work the traditional hub spoke model of having management somewhere. Because where do you put it? They're going to build this and then ship it to someone else. So again, from their perspective, being able to have a single place to keep all the content, single place for all the declarative information, the configuration. And we'll talk about this in the second half, the architecture, so I get to it in a few minutes. And this solves the problem for them, because before they would have to do this on a piece-by-piece basis. They'd have to stage it and build it. They'd have to send people out. Now they know that locally, whoever's operating or purchased that machine can put it in maintenance mode. And again, the feedback we've had is this must be in the control of the operator. You don't want this device trying to take an update in the middle of it doing a batch of drinks and then receive updates. So again, it's a very familiar with the kind of phone type model that you're used to. The end user dictates where updates go. So a good summary slide, increasing that agility, improving security and the sustainability. So again, save questions to the end. I've got a timer, so I'm tracking. We should finish good 15 minutes, 20 before the end. Energy and utilities, similar. So I'll move through some of these quickly, but again, I think it's important to understand where VMware can be used that you may not have seen before. This is the problem statement. You used to generate electricity centrally in coal, fuel, gas, nuclear power stations, and that was it. It's now grown that you have a lot more generation points, be it solar, be it wind, water, or even people feeding their own excess surplus into the grid. So I've talked about that. So this puts pressure on forecasting, on distribution, on demand. And that is increasing if we dig in one more. It's no longer static. There's crypto and AI demand. Demand spikes when those renewables are not working. And increase in manufacturing, and dare I say it as well, data centers. The rise of cloud is increasing the demand there, heat and air conditioning. So as I was saying, it's balancing that grid as a thing. It's a single entity. You can store electricity, but not to the extent that we'd like. It's becoming increasingly complex. Be it weather or the aging technology, it's generally measured in decades. It's way beyond what we see in any of the other industries. So we're working together. I'll talk about the alliances in a minute to apply those modern approaches to set the framework for the next 20, 30 years, effectively, of how the energy systems will be managed. And these are the typical problem statements. Then they shouldn't be uncommon to those of you who are used to working with VMware and IT. We want to reduce the number of devices, decrease operational costs, simplify asset management, collect and analyze more data, and standardize and interop. They're all key attributes. And again, visually, I don't have a video, but I have some photos. Aging equipment, lots of different vendors in a rack and lots of complex wiring. And the industry's started 5-10 years ago from going from lots of electromechanical devices into tens of these protection relays, apologies, just open the window, into single appliances. But again, similar to manufacturing, these single appliances are proprietary. They are powerful. They're centralized, but the goal is to convert them into software and software defined. And as you'll see on there, you'll see some other logos on there. We're not doing this alone. We are part of the wider partnership. So that partnership, if I jump through, is part of, it's called the Virtual Protection, Automation and Control Alliance, or VPAC. And you'll see some large industry players there. So from a hardware perspective, you have Crystal and Avantech. You may not have heard of them, but they're big industrial PC manufacturers. Dell, Intel, and we work with ABB, who work together in alliance to develop the requirements. There's published VMware validated solutions out there that mix the kind of, like you saw in manufacturing, mix the centralized stack with the near and far edge, the primary and secondary substations. We have our first UK customer, or the first customer pilot in the world on it, UK Power Network, and a number of pilots globally. And as I said, we've launched with ABB. And again, this isn't a plug for Explore, but if you physically want to see this, and at the shows, you'll see a full rack with Dell, ABB, VMware, and Intel, and you can go and talk to the experts. I think that'll be on the Intel. I think it will be on the Intel one for Las Vegas. There's a second alliance there around standards. An industry such as this needs standards to interop, more so if you're going to start software defining them. So the E4S Alliance, and again, there's some names you may recognize there. There's also a number of industry names in there and industry leaders in there. The likes of, again, some I've already mentioned, but Schneider are worth mentioning there. And some of the leading companies out there like UFD and IDE. So it's a global thing. What are we actually delivering? We're delivering software-defined solutions for the power grid. So whether it's on the management side, using VCF in the data center and the control room, or out in the substations, using edge compute stack, and again, the container runtime, the real time. There's a lot of new acronyms on there, but it is all about virtualizing that protection and control, virtualizing the automation and the human-machine interfaces. And then it's actually what one of my primary jobs is you see their certification of hardware. Again, this needs specialized hardware. I've mentioned Avantech, there's Dell and others, Crystal and SEL in this industry space. And that certification is around electromechanical interference. So again, we're doing specialized certification, working with these partners to ensure this whole stack works as it should do and is ready for 10, 20, 30 years of operation. The next part is to extend this with E4S into secondary substations. So the smaller footprint that you see out there, running containers and managing them. So this is an expanding thing, and it shows that as well as the value of our hypervisor, the value of consistent management and control is why people are working with us on this solution. So if I wrap this one up, I've sped through because I think it's slightly over. We talked about safety. Today there's a lot of wiring out there. I've got to thank a colleague for these photos, and the aim is to reduce it because less connections means it's safer. And this is probably far too detailed for a webinar, and it builds, but there's a huge reduction in the amount of physical cabling needed and terminations. So again, that's operational benefit as we've talked about it. Operational benefit because there's less literally hardwired dependencies in the solution. So that's utilities. Just going to wrap up with just mention again the real time, because both manufacturing and utilities particularly are all about that deterministic performance. So that means we know we're going to get the clock cycles. We know the latency is going to be consistent across the board. So this is the work, as I said, started with ESXi 7 Update 2. It's in our hypervisor, turn it on. We've done a lot of testing collectively and in our lab, and we persistently run. And when we get new CPUs, we work with the vendors to check, and then that starts to build the foundation. So to sum up utilities, it is about designing a proven standard architecture. That industry is all about standardization. The mix of real and non-real-time applications, the support for specialized hardware, and improving the provisioning. Again, if it's software defined, a device can be put in, it can be replaced, and then the noughts and ones be pushed down or put on staging. And being able to capture data from a single place in a standard way is important for the industry as well. So again, I'll shift on to retail. Retail, as I said, is probably where we have the most amount of prior coverage at the edge, if we call it that, people's stores and distribution centers, typically through IT workloads, and then, batch-based retail applications. So things like pricing updates at the beginning of the day, sales data at the end. What I tend to phrase as slow moving, it's not real time, or wasn't. So what do retailers actually care about? If you think about a retailer, it's all about selling the most amount of goods, so having the right levels of stock at the right price to the right people at the right time. So what they focus on is, number one, top line growth. Second is margin protection. Retail is probably the most margin sensitive business I've ever had the pleasure of working in. Cost control. So that means being efficient everywhere. No wastage, efficient processes. And unfortunately, in this day and age, and increasing, and adding security also on the end of every slide, is making it a safe place for customers and employees to work. They all need to be addressed continuously, and focus might shift from one to another, but there is always a need to address these three in their operating model. So if we flip to the consumer's point of view, what you and I and others want when we go into a shop, we want an experience. People, a lot of brands are virtual now, and I've used the acronym IRL. I learned off my daughter, in real life. Now, that's all about going and experiencing that brand, touching it, feeling it, getting to know it, and having them know you as well. So that requires data on both sides. Consumers want value. They want the right price. We can shop around now. Loyalty is, very low in certain areas now, hence why they focus on experience. You want convenience. If you like me, quite often like to just get in and get out and get the stuff. Getting your lunch, in busy cities is the prime example there. So again, how can technology help that? And the final one is the journey. It's all about knowing where you as a customer are in the journey. And I think that's the bit that people value the most. And to me, all this is service in the traditional sense. We like experience, we like curation. I like my music, I like going to record shops and being told what to look for. But we also like the digital equivalents of that. So that's what consumers care about, and you can see it might be opposed. So there's a lot of use cases out there that are being applied in the retail space. You can see them categorized here. You've got customer engagement. These are the ones that get the headlines, get the news. Contactless kiosks, digital mirrors, pick and collect. They need to work, otherwise consumers get dissatisfied and jump on social media. There's the underlying operational efficiency. Knowing what's going on, some of those common with other industries. Where we see a lot of the investment going is in security and safety and business insights, the two grey areas in there. So understanding what's going on in stores and are they being run efficiently, that capture of data, that clickstream at the edge, but also security and safety. And that is, isn't just about fraud and loss. That's a big thing. It contributes typically, 20-25% to any large retailer. And when you're on a low margin, that can make a big thing if you can address that. But it's also about safety of employees, and it's about automating tasks. So in the old days, you might have someone say over a tannoy that there's a spillage in one of the aisles, or when you go to a fuel or petrol station that there's diesel on the floor. Now you can do that with cameras. So again, it's about safety, efficiency, and also driving the next task, so that employees can focus on the interesting things, which is serving customers and giving great experience, rather than checking if an item's out of stock, or being pulled off serving a customer to go and deal with a safety hazard. But the key here for us in IT, as I've said, that the platforms have existed in IT a number of times, is how to do this and offer the resilience people need and that agility within the constraints of retail economics. A lot of these stores are in remote locations with thin lines, and they don't always warrant the investment that you might see in some of the other industries. So that's the kind of balance we're trying to achieve in the retail space. So if I pull this together, this is the view I take. On the left-hand side, you've got those kind of underlying features in retail that we're trying to address. Retail is built on its operating model. It's why I love working with retailers. They know how to build stores, refresh them, get the fresh bread out. It's all about scale. They do that by optimizing and taking data points. The cost and right sizing is all about looking at how efficient you're doing things, ensuring things are predictable. And of course, risk mitigation. It's all about data out there. You might have your own IP out there. You might have customers' data out there. So a lot of these were done physically beforehand. And because you had a lot of people in retail, you could find workarounds for them. You know, you could just put more people on the checkouts or whatever. If you've made that all digital and technology-wise and you don't have the resilience, what's your answer? Shut the store? So there's some fundamental things here where retailers are becoming dependent on technology rather than using technology. And that's the opportunity for those of us in IT to help and evolve these platforms. But as I said, it's not a slow-moving platform anymore. You also need to address the right-hand side, the agility side. Arguably, Edge is the last cloud to be built out, or more to the point, the last space to have cloud-like attributes applied to it. So treat it as cattle, not pets. Be able to mass deploy an application out everywhere. You also want agility. So we talked earlier about hockey stick type scaling. You get a great idea, you know, the blue and green on that prior slide, and it makes a headline, which is great, but how do you then get it into 1,000 stores? And that's where a lot of retailers and the app vendors are stalling and where we can help. And the last is choice. You know, choice has been something that VMware has always prided itself on, what you run on and what can run on top. When you get to the edge, you often get that singular device. So people don't want something that the next project can't land on. They want an open platform. And again, that's been one of the common goals. So I said before, IT is not new in most of the, I'll call them big box retailers, groceries, home improvements and others. And they started where manufacturing utilities are today. One server, one app. Most of them, if they've had the need for compute, have got to the middle bit today, where you have different t-shirt sizes depending on the services you run, depending on the turnover of the store, how big it is, or its location. But the problem is that's still quite static, and it's a static deployment. And if you need to add a new application fast, and retail is all about reacting, you can't, because you need another piece of hardware and you need to plan or change the t-shirt size. So what everyone's aiming for is this future platform type approach with an adaptable platform where you can scale out as needed. You can support the existing workloads, what I call the stuff that runs your business today, but also that new innovation, especially as some of the retailers that have landed in the cloud now extend those capabilities down to the edge. But the question is, when are you going to do it? It's very cyclical. I used to have 5 years on that slide, and feedback from retailers is, no, we're 7, we're 10. There's quite often, you know, a bit like utilities, you know, once in a career, I won't say once in a lifetime, opportunities where these retailers can transform the edge, and they're looking to get the most from it. Some have skipped the middle bit, and today use point of sale and cloud or private cloud-based apps, the big app, little app, as I referred to earlier. But what they're now seeing is those use cases are requiring the need for edge compute. And again, they want it to be small, agile. They want it to be silent. They may not have racks and those protected environments, those with some heritage of IT at the edge. So to wrap this up before I show you a couple of examples, these are the challenges. One is that scale up and out, hockey stick type curve. That's what every business aspires to when they publish one of those. You know, this is a great idea. We put it in our anchor store or, you know, our concept store. The ROI that app promises If you can be the enabler to get that into every single store, you're going to be the hero. The middle one is the hard one, especially for retail, is predicting that demand and investment. How much compute do you land? How do you make that platform flexible? So we firmly believe that a platform approach is required. But I can tell you from experience, it takes a while. We're talking about disaggregation, bringing things in, working with a lot of new startups and ISVs who are delivering those applications you see, smart mirrors, computer vision, smart edge labels, and others. So my message to everyone here is, the platform vision sells very well. As you know, it works. It works in private clouds, it works in public cloud. But the key is to find an opportunity and be use case driven. So find that anchor, I use that word again, use case that will provide the initial funding, the modern app that needs some of those attributes that I put a couple of slides back. And then you can feed out. So just to close on the retail section, and then we'll get into the product. A large EMEA European retailer, here's an example of the use case. So they're taking feeds from camera systems. They have their traditional workloads on there in their store service, but they also have a video application that takes pertinent information. So if you think of when a police officer might click their camera and say, I'm recording. So if there's an incident or something of interest, they can send that up to case systems, make it available as needed, whether it's for safety, security, or just general view. And that means they're capturing data locally, they're snipping it on demand and sending it up. So this is an example. And then the benefits the product can bring is how fast they can redeploy if there are losses. Not every site warrants a full resilient platform. This is common across a lot of the large scaled retailers. Some sites just don't warrant it in financial times, and the ROI economics is done on a per store basis. So you have to rethink what you mean about resilience. So resilience to them means how fast can I get the business service back up? So as you'll see when we jump into the product, the benefit here is we can have everything in a single configured place declaratively, and it can be used to deploy. So before I jump on, one industry example that's a great story to think about and shows where our tech can be applied that, before I got involved, I was like, you'd never think of this. So bridges need to be maintained. This is a European country's highways agency. And they have the need to have sensors under every bridge to ensure that there's no issues with the bridge. There have been failures in the past through construction or just corrosion over time. So you've got 1,000 locations, no strong connectivity, a single app in this instance, but they need management and they need control, and they need to be able to, zero touch provision is an understatement. There's no IT, it's a cabinet under a bridge. So before they were driving around and manually doing sneaker wear. So this is a perfect example of infrastructure as a code. You can take a device to one of these locations, connect it, register it, and the data comes down. That's the perfect example of a use case. It might not be relevant to your industry, but it means next time you see a cabinet under a bridge or whatever, that could be running our platform. So I'll shift into the second half, the architecture piece. A little over, but I'll keep the speed up. Edge Compute Stack 3.5 was released a couple of weeks ago. So I'll provide some of what's new there, overview and architecture. But I think we're all agreed by now, Edge is different and has some unique challenges, be it that scale, the networks, the specific protocols, lack of personnel, and the underlying need for security. So our value proposition here is threefold and involves two primary components. One you may know and one you may not, and we'll work through that. We want to optimize that runtime at the edge so it fits on the hardware that's right for the use case. So that means things like lowering the cost of entry, certifying smaller network cards or others that may not be in the mainstream DC. We want to be able to support all the workloads, the real-time workloads. Clearly, operations is key here. It's really about our platform and how we manage at scale. And then flexibility. So if you need to swap it out, if you need to increase the number of apps there, if you need to scale it out. It's easy to do. It's easy to swap. As you've seen on some of the prior slides, there's still a refresh mentality at the edge because of cost and complexity, which is why people only do it every 5-7 years. If you take one thing away from all of this, my ask is start thinking about the edge as a platform, as you would your private cloud, public clouds, where you're taking demand, you're looking to the future. And, if the economics mean you can refresh that hardware in a couple of years' time because there's new use cases and grow it, that should be the way rather than having constrained compute. So they're the things. And we're doing it, as I said, with two things. We'll expand on this on the next slide. The edge optimized runtime is based on ESXi that you know. There's value there in terms of abstraction, security, stability, heritage. It does its job. And then we have the orchestration. Whereas I said, I'll dive into it now. We're taking a slightly different approach from that you might see in private clouds. In that, we have a pool-based model, as I've said. So rather than all these hosts being talked to from the center and the host needing to understand from the center, are they part of the cluster? What's their configuration? Think of these as individual autonomous sites. You have a control plane, VMware Edge Cloud Orchestrator. We abbreviate it to VECO. It shouldn't be, but it's stuck somewhat. And then we have your content in Git. I'll dive into Git if you're not familiar with it in future. But think of infrastructure as code, but not just infrastructure, the applications and the VMs, the whole stack is defined in code. And then how we're doing this, we've got an edge agent that effectively is it's something that was introduced late in version 7 of ESXi called the improviser. We don't publicize it, but it allows us to bootstrap and effectively run CRXs, small containers, that allow us to bootstrap and manage that host connecting in. So if we look at how this looks from a provisioning perspective, it is as simple as being able to, put the config into the orchestrator ahead of time via the UI that I'll show you briefly in a demo or full on. Ship that hardware to the location. You can install some of the noughts and ones. We found that's been quite a common ask. Just because, again, these sites are remote, and why ship an empty box unless it's a DR scenario? Again, cost and efficiency. Plug it in. It connects and registers. It's only using an outbound connection, HTTPS, so we can do it over public networks, unsecure networks as needed. Calls home, authenticates, config, downloads the workloads. And then post that initial provisioning, you can use it for lifecycle management and onwards. So if I dive in there just a little bit, this will help when we come to the demo in 2 slides' time. If you think about it, we're shipping just as you would from an OEM, whether that's installed on the disk or it's an image of some sort. As I've said, you can preload the information into the console as you would. What the make, the number, the serial number, what apps and tagging that you need. That's standard operational database config. Power it on. And in experience, we were talking about, limited human involvement. All our feedback in design is no involvement. So if you're used to consumer type devices like this, you literally plug into the one with the blue mark on it and plug the yellow cable into the yellow one and off you go. As long as it can get outbound config, it can do it. Connects to the Edge Cloud Orchestrator, activates and receives its information. So from an architecture perspective, we drill into what's happening under the covers. How are we doing that? I'll start at the lower half of the diagram. As I said, we've got ESXi hypervisor there. We have the improviser that allows us to bootstrap these components. And we have 3 things there: the control plane, an upgrader service, and a monitoring service. The upgrader service is important because it allows us to effectively do that kind of blue-green. You don't want to get into a state where an upgrade, if it fails, you can't roll back. because it's all about recovery time objectives on these sites. We have the monitoring service, as I've said. We have our edge optimized Kubernetes runtime, and then the ability to host VMs as you normally would. On the top half, you have the Edge Cloud Orchestrator, which is currently a SaaS service. So we've launched it aligned to the SD-WAN, the Velo Cloud business. That brand name is back. And we will have on-premise is planned on the roadmap. The two boxes to the left are end user, customer owned. You have your Git repository, which has all your config, and then you have your content. That might be OVAs, container registry, and that can be in the data center or cloud, or it could be local on the edge site. We've had some asks for recovery that other methods are used to sync that, CDN and other type things. By default, there's a heartbeat interval of 1 minute where it pulls and sees if there's any requests. That's configurable. And again, working with defense and others, the requests coming in are, be able to switch it off, radio silence, have it never update sometimes, and use this tool for provisioning. So one final slide before I walk you through a quick demo. I mentioned GitOps a number of times, and if you're familiar with it, take a break. If you're not, sort you through it. So GitOps is the ability to define things in code. YAML stands for yet another markup language. And what's important here, and I think people miss it sometimes, is we're not just having the config for how the firmware boots and the hypervisor, but also the container runtime and the apps, the VMs and containers. So the first time we have a product here where all the individual layers can be brought together in a single state. All the teams can work together feeding this. It can all be their own contributions into the kind of edge GitOps collection. And that allows us to deliver on a lot of things I've talked earlier. How do I refresh? How do I recover consistently? How do I avoid handoffs between teams? In our experience, those handoffs are often the thing that causes the biggest outages outside data centers at the edge. One team has to do something and pull their images down, then someone else configs. This speeds it all up, and that's one of the massive benefits of this. You can run a set of tests and pull it down. So if I start this demo, what you should be able to see is there's a console, part of Cloud VMware, and the service is called Edge Cloud Orchestrator. If you have an organization and it's not on there, you can add it. We'll talk about how you can do a trial at the end. So if we kick this off, first thing we do is going to launch the service. This runs for till 3 minutes, and register a Git repository. So my colleague, our lead PM, Anna Runef, he's got a load of examples on there, and I'll provide the link. So he's registering it and he's defining a site. Next thing we're going to do is download the ISO. Again, this could be pre-loaded, but while he's doing that and connecting it, again, this should be familiar to everyone who's worked with ESXi over the years. Connect it and you'll see it boot and launch and install. And the key here is making a note of the serial number and the host. So what he's now going to do is set up a site. Again, this can all be done programmatically ahead of time for purposes of helping people understand the concepts. We run it as a demo. Adding a new host, associating a Git, see the credentials and access token go in, and applying some labels. So saying this site needs the computer vision one, it might be part of this kind of site profile. And you can see here, it's got those 3 labels. What needs to be applied, the site ID and computer vision. So we're about halfway through now. So next thing is to add the host. And again, this can be done automatically. You can see all the servers out there that are on the VCG, the HCL. We've also been working with industrial PC manufacturers. We just added the Siemens industrial PC, the BX39, one of the leading ones. Compatibility. Selecting a site. Again, you're going to use the same for the host. Which branch? Apply key values. Add the host. Refresh, you can see it's not active. So you can click activate. So the next time that host connects, it's going to be told it needs to activate. We have the key, we know the shared pair. And you could use TPM for this. Again, we're using serial number as a pair. So you can see the events here. It's registering, it's connecting. So while we're doing that, what we'll do is just step out, and whilst the host is updating, is go into GitOps and look at the ECX config. These samples are available. Send a link at the end. You can read through. You can see all the config is stored there. That can be for a single site, can be for multiple sites. All the benefits you'd expect of GitOps, layering, nesting are there. What you can do is just going to change the welcome message there. There's the ability to lock down the console so that people can't log on locally. Again, ticking the security piece there. And he's also looking at the computer vision app, just checking the port that's launching, 5,000. So in a second, you'll see us launch the port. So at the moment, we've registered the host. It's configuring itself. It's downloading these apps. We're just going to commit and push those changes. Computer vision and ESXi config. If we jump back, we can see the host is online. There's monitoring and metrics and events there. I've got a couple of slides if this is running around too quickly. If we launch, just grab the IP of the host and launch the app. So on port 30,000, you can see there's a computer vision app running there on our container stack showing robots. If you launch the console, you can see what we edited in the YAML there. And that's the boot screen. There's no ability to log on. That's been disabled. So finally, what about a VM? So there's a Windows VM here. Again, you can see all the config in here. Apologies if it runs through fast. There is a video on YouTube, Windows 2000 OVA, and there's a little hello world text file you can see being piped there into a text file from command. So again, commit the changes, push it, allow the noughts and ones to do their job. It's deployed, jump into there, and on the disk in documents, you'll see effectively hello world. So covered quite a lot there as we ran through. But the point is you've got a single place here and a single console as code to configure your entire stack at the edge at scale. So we've got 20 minutes. So 2 or 3 more slides and we'll wrap up. So just re-showing that slide again. What you were seeing there is multiple different pieces of config stored in Git, standard continuous delivery method being used to configure the hosts at different edge sites. I think in the interest of time, I'll just jump through these. There are examples on the web. Good to open up for questions. As I said, each component is configurable for virtual machine. You support Linux and Windows. You can use VM class to determine the CPU and RAM. Disk is controlled by the OVA template. And if you're migrating, the existing OVAs or the existing disks can be used. And we've also, if you're aware of the VMware or the Tanzu catalog, it was originally from Bitnami. There's still the public Bitnami catalog. There's some examples there, the typical WordPress and Postgres and other databases that you can use for samples to access. For containers, similar experience here. They're deployed via YAML using the Git. The OCI compliant registries can be supported, like Harbor and others. And I'll provide the example when we share the content. That's my colleague's Git repository. You can also use it for lifecycle operations. So it's not a one-time thing. Once the app is out there, you can update, you can delete, you can scale it. And you can decide how to do it. And I think this is an important thing. No one wants 10,000 hosts updated at once. In our experience, it's again a hockey stick or a linear curve. It's do 1, do 2, do 5, do 10, do 50, then just do the rest. So that's what this allows you to do and have the agility. Scaling as well. If you wanted to scale an individual app up, in this case at Kubernetes level, you want to increase the number of replicas running. This might be a scraping app. So I showed for that bridge analogy. You want to run more of those containers, that's exactly what you can do. Of course, every product needs a UI, and as you've seen with the UI, we're building in host monitoring. We're building in the ability to have geographical location, for those of you aware, with our Velo cloud product, the SD-WAN, some commonality in the user interface there. We're also giving the ability to feed this into other systems. We're very aware, especially for customers, who have estates with us, that single service and management view is important. So the ability to feed these events up into the likes of area operations is something we've made available. Because everyone has their own logging, service management, the goal there being to, if there was a hardware failure, to raise a ticket so someone go and replace it. And this slide shows it as well. So just to wrap up, we're on the final sprint of slides, 3 or 4. Thank you. What you've seen there is us dealing with scale. Dealing with a limited network, that's a pool-based. I'm often asked what bandwidth is required. What's the ultimate scale? The answer is it's based on your network. And as I've said, we've already had customers ask for staging or local container and repositories as needed. On-site personnel, this is designed to be no touch, or as few touch as possible. And because it's all configured and controlled in a single place, it allows us to, address the security needs. What's available today? Roadmap is, as ever, evolving. Please give us feedback. There's some links. But fleet management, the orchestration, as I said, SaaS delivery model, flexible deployment, so where you place your repositories, in the future where you place the control plane, and the monitoring piece is evolving as people give us requirements. Our intent is to provide enough in the product, and then everyone has their own monitoring tools, especially when you start to talk to app teams and move away from the hardware and infrastructure tiers. So they want to be able to feed it into Splunk and Prometheus and these sort of things. So whistle stop tour. Appreciate for those of you who've been listening. 3 summary slides and then some follow-up. So manufacturers are using this to improve their operational efficiency and agility by taking a platform approach and virtualizing OT workloads. Utilities are doing it to reduce operating costs and build the future, the next 20 years, doing that in partnership with a number of alliances. And retailers are using it to improve their store operations. And there's that balance between getting new apps out fast, single use case, and building that platform for the future. In terms of follow-up, if you're keen to learn or try more, there's a blog out there. There's a video in 2 minutes, ECS 3.5. There are some more detailed ones being published. You can contact myself and the product team at steedgecomputestack.pdl@broadcom.com. Or, as Amy pointed out at the beginning, please follow up with your TAMs and they can find us. If you're going to be exploring the US, there are a set of sessions on Edge Compute Stack, ranging from a high-level overview, architecture deep dives, and we're also working on expert sessions and hands-on labs, so expert-led and self-led sessions, as well as meet the expert sessions. We'll have a similar set of schedule for Barcelona and the other global events. So just to close, our goal is to have that edge-optimized system. In the past, there's been a lot of workarounds and customizations that people have done. We've seen them all. A lot of them are very clever. Our goal is to, effectively bake that into the solution so that things are easier. Fleet management is possible. Automation is possible at scale. Simplify that operational journey and be flexible. I think if you followed the entire presentation, every different segment we work in is completely different. It's different in terms of hardware, in apps, in terms of connectivity. So this has to be flexible and adaptable. Just want to say thank you. If you've got any questions, we can open it up. And as Amy said, the next session will be on August the 15th, vSphere 8, Update 3. Thank you very much.
Thank you so much, Chaz. That's been an amazing session. I have to say, I didn't realise there were so many use cases for Edge myself, so it's been great to hear all about them. I don't see any questions in the Q&A that haven't been answered. Just a reminder, if anyone does have any questions, feel free to drop them in. We do still have about 10 minutes, so I'll just give it a minute and see if any questions come in. If not, then we will close the webinar for today.
Thank you, and thanks for the invite. And as you said, yeah, I'll put the, let me just jump back to where people can never buy a clicker. There you go. Try it out. For those of you with home labs, you can use an Intel NUC or any other device. That's what our team used to work on it. So thank you very much.
Cool, thank you. Okay, we've not had any questions come in, so we'll close there today. Thanks again for your time today, Chaz, and for that great session. And thank you to everyone who joined us. As we mentioned, this presentation has been recorded and your TAM will be able to make that available to you in the coming days. Please join us next month where we'll be looking at what's new in vSphere 8. We look forward to seeing you again. Thank you, everyone.